In the previous class, in class 22, we discussed calculation of internal resistance and also comparison of two EMF. Let us see, that is the last class, and we have completed this current electricity. Now, let us see the JEE previous main problems, and we will end up this chapter. Now, a battery of, this is given in JEE main 7/1/2020 shift 2. JEE main 7/1/2020 shift 2. A battery of unknown EMF connected to a potentiometer has a balancing length of 560 centimeters. If a resistor of resistance 10 ohms is connected in parallel with the cell, then the balancing length changes by 60 centimeters. If the internal resistance of the cell is n by 10, then value of n is, as in value of n. Now this is the integer type. This is integer type. So don't be panic as soon as you look into the problem. Just if you read the problem, if you recollect the content, then that is very easy to you. Now, a battery of unknown EMF connected to a potentiometer has a balancing length of 560 centimeters. Now let us see, this is the initial battery, this is the resistance R, RHR, and this is the plug key K, this is E, and this is connected to a wire AB, a current I flows, and to this another battery of EMF, let us say E1 resistance R connected and here a resistance parallel to it is connected, a galvanometer, and this is galvanometer, this is jockey J. This is resistance R. Here a plug key also connected, key K1. See, we have discussed this in the class 22. Now, initially the resistance was not connected. The resistance R is not connected. A battery of unknown EMF connected to a potentiometer has a balancing 560 centimeters. So, what is the balancing then? E1 is equals to I rho L1. Therefore, L1 is equal given as 560 centimeters. Keep it aside. L1 is equals to 560 is given. Now, if a resistor of resistance 10 ohms, this is 10 ohms. Resistor of resistance 10 ohms is connected in parallel with the cell, then the balancing length changes by 60 degrees. Change in length is equals to 60 centimeters. Now see, first Q1 is not connected, only E1 is connected. In such a case, the balancing length is found to be 560 centimeter, that is L1. Now, a resistance R was connected in parallel with the EMF E1. Now what happens? It's connected now. Key K1 was closed. Now R is connected. Initially, in calculating L1, R is not connected. Now connect R. Now calculate L. He is giving, what is giving? See, read carefully. He is giving the change in the length by 60 centimeters. He is giving a change in the length by 60 centimeters, not giving the second balancing length. It's not directly giving the second balance. This is the key point here. The change in the length is, balancing length is 60 centimeters. Therefore, what should be L2? L2 should be equal to either 560 plus 60, that's equal to 620, or L2 is equals to 560 minus 60, that's equals to 500 centimeters. Now, I told you clearly in the class 22, L2 less than L1. Therefore, L2 should be equals to 500 centimeters. L2 should be equals to 500 centimeters only. Now, we had derived this expression for R. R is equals to R into L1 minus L2 by L2. I have derived this expression for internal resistance when the resistance R is connected in parallel in class 22. In class 22, I have derived the expression. Therefore, R is equals to L1, my internal resistance R is equal to cell is equals to this R. R is equal to R into L1 minus L2 by L2. Therefore, R is equals to R into L1 minus L2 by L2. What is R here? Here R is that is equals to, let us capital R is equal to 10 is given. Resistance of, what is given? 10 ohms. Resistance of 10 ohms was connected. 10 into L1 is 560. L2 is equals to 500 by L2 500. This is 10 into 60 by 500. That is equals to 6 by 5. 6 by 5. That is R. Therefore, R is equal to, we got 6 by 5. But what is given? Is given R is equals to N by 10. Therefore, N by 10 is equals to 6 by 5. This implies N into 6 into 10 by 5. 5 2s. That is equals to 12. Therefore, the value of N is equals to 12. Very simple problem. If you remember this formula of interrelations, and if you observe, not the length L2, this is the length, change in the length. From that data, you have to calculate the actual length L2. That is the key point here. And if you remember this formula, you will easily get the answer. Now, let us see another one now. Now, let us see next problem. JEE Main 9/1/2020 Shift 2. JEE Main 9/1/2020 Shift 2 here. If a meter bridge experiment, if a meter bridge experiment the balancing length L was 20 centimeters as shown in the figure. If the length and diameter of the wire of resistance R is made half, the new balancing length is the new balancing. Therefore, no options are given. That maybe this also integer type. Maybe this also integer type only. Now, let us say this is resistance R, this is another resistance X. For the balance length is L1, L remaining is 100 minus L. Meter bridge length of the wire is 100 centimeters. The balancing length is L, remaining length is 100 minus L. Therefore, what we have, R by X is equals to L by 100 minus L. By the principle of meter bridge, R by S is equals to L by 100 minus L. We have discussed this also in a previous class. Therefore, R by X is equals to L by 100 minus L. This implies R by X is initial is given 20 centimeters. 25 by 100 minus 25. This implies R by X is equals to 25 by 75. Implies R by X is equals to 1 by 3. Say equation, let us say equation 1. R by X is equals to 1 by 3, or X by R is equals to 3. Or X by R is equals to 3. Or X by R is equals to 3. Say equation 1. Keep it aside. Now, what is giving? If the length and diameter of the wire of resistance R is made half, length is made, new dash, L is equal to initial length is L, then the new length is L by 2. Diameter is made half means radius R also made half. Diameter is half means radius also made half. Therefore, R dash is equals to R by 2. The length and diameter of the wire of resistance R is made half the new balancing length. Now, L dash and R dash same wire. Therefore, we know that R is equals to rho L by A. R is SL by A or rho L by whatever it may be. S is specific resistance. S is specific resistance. And L is the length, A is the area of cross section, and A is equals to pi R square. Therefore, now R dash is equals to SL dashed by pi R dashed square. Okay, R dash is equal to SL dashed by pi R dashed square. This implies R dash is equals to, specific resistance remains constant because we are using the same wire. Therefore, S into L dash is equals to L by 2. The length is made half into pi, radius, diameter half means radius gets half. Therefore, pi into R by 2 whole square. Instead of R dash, we get R by 2 whole square. This becomes SL by 2 into pi R square by 4. Therefore, 2 times gets cancelled. Implies R dash is equals to 2 into SL by pi R square. But 2 into SL, that is equal to 2 into SL by A. 2 into SL by A. A is equals to pi R, 2 into SL by A. But SL by A is equals to R. This implies R dash is equals to 2r. R dash is equals to 2r. Say equation 2. Now r dash is equals to 2r. Now this circuit becomes, this is r dashed and this is resistance x only, and now the new balancing length is, let us say, L dash. This becomes 100 minus L dashed. 100 minus L dashed. So after r, this is r dash. This is r dash x L dashed and 100 minus L dashed. Now what is the principle? R dashed by x. Now r dashed by x is equals to, r dashed by x is equals to L dashed by 100 minus L dash. L dash is the new balancing length. L dash is new balancing length. L dash is new balancing length after changing the dimensions. Now therefore r dash is equal to 2r. No, therefore this implies r dash is 2r. Therefore 2r by x is equals to L dashed by 100 minus L dashed. But we have got already r by x is equals to 1 by 3. R by x is equals to 1 by 3. This is equals implies 2 into r by x is 1 by 3 is equals to L dashed by 100 minus L dashed. Implies 3L dash is equals to 200 minus 2L dashed. Implies 3L dash minus plus 2L dash is equals to 200. Implies 5L dash is equals to 200. Implies L dash is equals to 200 by 5. That is equals to 40 centimeter. Therefore, the new length is L dash is equals to, the new balancing length after changing the dimensions is 40 centimeters. Very simple. Only technique is principle of this this meter bridge, and he has used the resistance relation between with length and area. R is equal to SL by A. Now R dash SL dashed by pi R dash square. Let us calculate R dash. L dash is equal to L by 2 and R is equal to R by 2, and the value of R dash substitute in the formula. Okay. Now in the next, with this we can come to end of current electricity. In next class we will start modern physics. Modern physics, atoms, photoelectric effect, and nuclear physics and matter waves. All this we will continue in the next class. Thank you.